My name is Brendan Sheppard. I'm CEO of a company called Smart Factory Solutions, and I'm going to give you a slightly different angle on what we believe is the factory of the future. Oh, you've here. Is that, is it? Okay. No problem. Okay, thanks. There we go. That's it. Okay. So I'm sure a lot of you have seen the McKinsey report. If not, I would recommend you take a look at it. It talks about the potential value of IoT in a global economy and also around manufacturing in particularly. So if we look at their prediction between now and 2025, they're saying that the potential value of IoT could be anything up to $3.7 trillion per year. So that's a vast figure. Dell have also done an analysis of what devices are being connected. And I think this is an interesting chart as well. So if you look at manufacturing, it's around about 10%. Now, I think that's quite a low figure, but that's what their predictions are, that as things stand, about 10% of manufacturing environments have devices being connected back to give operational insights. Okay, so that's all sounding fairly positive. Lots of money, and there's some interesting data on the factory floor. And then you get onto this, which starts to make things look a little bit different. So this is another Gartner report, and it talks about the hype. And to me, this is one of the big watch-outs. There's an awful lot of hype around IoT. And I think we need to be realistic and say that a lot of the technology that's emerging is so this is where they're saying it's the IoT platform. They're saying 5 to 10 years. And unfortunately, before we get there, we're going to go through this trough of disillusionment. And what that means from my perspective is we're going to make all of this noise about IoT, and a lot of people are going to go through a lot of pain before we really find out how good is IoT in relation to the factory floor. Okay, I think this sums it up really. This is the online slang dictionary, okay, and it talks about hype. The definition of hype is anticipatory excitement, especially when actual things don't turn out to be as good as they were expected, okay? So I think we need to look at all of the noise, and a lot of the speakers today, a lot of people talking about IoT. There's an awful lot of hype out there. Okay, this is, I'm just going to play this video. Looks like my video is not playing. So this is a line that we put a data collection system on about 5 years ago. So way before IoT, way before hype, way before. It's a high-speed production line running at 180 units a minute, changeover times of less than 1 minute. There's 14 robots, there's 18 PLCs. We know every sensor, every PLC. We know the status of everything in real time. We've gathered all the data, we're bringing it back into a visualization system, and you think, okay, this is surely the factory of the future. It's high speed, it's almost autonomous, the changeovers are happening automatically, and you think this looks pretty good. The problem is that this line 5 years ago was designed for data acquisition. So before the line was assembled, before it was built, the designers, the engineers got together with us, and everything was laid out to be a data gathering system. Okay? What we find in real terms nowadays, we go into a lot of companies, they have legacy machines. They have machines that might be 20 years old, perfectly good machines, but they have no data. Another huge problem that we encounter on a daily basis is this. This is a very common situation in manufacturing in Ireland. There's no PLC, there's no high-speed production, it's a validated process, there's critical temperatures and sensors, pressures, different critical processes around the line. How do you apply IoT to that? So they'd love to say, yeah, we'll take the humans out, we'll let the robots do it. Realistically, it's not going to happen in the next 10 years. So this is the problem that we've been presented with. This is what we call a manumatic process. So we've got humans doing manual jobs, and we've got automated steps in that process, and the humans and the critical process parameters need to be gathered. So what data are we going to get from the humans? A couple of more critical features around this is getting downtime on a process like this. So if I want to go in and put in some automation in here, it's very difficult to plan to get downtime, and also it's a validated environment, so I need to go back and revalidate it after I've made my changes. Maybe I can gather the data in a couple of days, but the validation process could take weeks. Okay, so I suppose what I'd like you to take away from my brief talk today is there's some real challenges facing manufacturers in Ireland in particular, because we have a lot of discrete manufacturing around IoT. Number one for me is security. If you don't have the right security built into your IoT infrastructure, the potential problems are huge. Again, from another Gartner IoT report, by 2020, so 3 years' time, 25%, it's predicted that 25% of attacks will come through IoT devices. Okay? If you think about that, that's a really serious problem. How many of you remember the Betamax situation? Betamax was better, VHS won out. How do any of you know what technology to use in terms of talking to devices on the factory floor? We have some views on that, which I'll show you in a couple of minutes. What do you do with legacy equipment? I have, so many customers that have really good machines that are making good product every day, and yet they've no way of getting the data from those products. And then what happens if you have a manual process? How do you gather data from a manumatic process? Manumatic is partially manual, partially automatic. Okay, so the first point. I don't know what it's like in any of your companies. I know in most of the companies that I work with, the IT guys don't trust the automation guys, and the automation guys think the IT guys know nothing. Okay? So there's a huge problem there between IT and OT. So for me, the number one step is you have to assign ownership to this new IoT technology. Somebody has to be responsible to say, what devices are we bringing in onto the network? How are they going to work? And who's responsible for the layers of security that need to be built in? You need to have security practices. In the same way, if you have an IoT, an existing enterprise network, you wouldn't bring in a laptop from some guy that you found down the road and plug it into the network with a USB key that you picked up off the ground and hope for the best. So you have to do the same. So if you're going to put in IoT devices, you need to design your network in a way that security is built in. Not that it's an afterthought, not that you go, oh, we didn't think about that. Let's let's look at a firewall or something. It has to be built in from there. So the infrastructure, people are trying to put IoT devices onto an enterprise network. And to me, that's not the right approach. You need to start with the network, design the network to take your IoT devices. We have a lot of information, folks, on our website if you're interested in security and security risks. There's a very good report from Gartner, and I'd recommend it. It's on our website to download. I'll show you the link at the end. I'd recommend that you get a copy of it. I'm sure you're all familiar with the ISA. We believe that the standard for bringing data from the factory floor level up to the IT level is OPC UA. I don't know if you're familiar with OPC. OPC has been around since the 1990s. OPC UA is the latest version of that has security built in. And the reason I believe this is going to be the future standard for machines talking on the factory floor is because these are the companies that have all said, we believe this is the protocol that we're going to use. Siemens, Rockwell, Grundfos, ABB, Cognex, Festo. It's the only technology, it's the only protocol I'm aware of that all of these companies have said we will all develop OPC UA drivers to be able to talk to, for machines to talk to each other. So this is our vision of the factory floor. This production line could be 10 years old, could be 20 years old, it doesn't matter. It's got wireless devices, all secure as possible, built in on a network that's being designed for wireless devices. We're recording via OPC into a historian, back into a database. We're picking up wherever there's a PLC, but in a lot of cases there mightn't even be a PLC. So we're using light stacks and other wireless sensors to gather that data. We've installed a system on a medical device plant recently, and within 30 minutes from walking onto the factory floor, we had data coming from their process back into an SQL database. In the past, in that robotic line that I showed you earlier, that would have taken me probably 4 or 5 days. That's why I believe this is going to be a disruptive technology. This is what we call our Manumatic data entry system. So this is a tablet. It's got, depending on where we are in the process, if I select here, then I get different options in terms of the data that human can enter. But it's also communicating to wireless sensors, so I can calculate the rate. I can see I should be making 20 units a minute or 20 units an hour. If I go outside that rate, I can trigger a light to say it's going too slow. And obviously it's communicating back to the light stack and it's communicating back to the process via OPC. So we have a link on our website, smartfactory.ie, what you need to know. To me, the big takeaway is security, designing your network in a way that it's enabled and ready to take wireless IoT devices. Thank you.